You need to hear this if you're a space enthusiast. How do we stitch together these incredible machines that dance among the stars? Let's unlock the secrets. First up, the structural framework. Think of it as the skeleton of a spacecraft. We use lightweight aluminum for sturdiness without the bulk, and titanium alloys for unbeatable strength. Don't forget carbon composites, adding that extra layer of reinforcement. Now, every spacecraft battles extreme temperatures, which is where thermal protection comes in. Ceramic composites and carbon tiles shield our space explorers from temperatures that could melt metal. Next, let's talk about the invisible shield, radiation shielding. Using materials like lead and even water, we protect astronauts from cosmic radiation that could pose serious health risks. And what about seeing the universe? That's where optics and sensors play their part. With precision-made glass and sensitive semiconductors, we capture images and data from the depths of space. Don't forget the solar arrays. These panels, equipped with photovoltaic cells, harness sunlight, turning it into vital electricity. They're not just efficient, they're built to last against the harsh conditions of space. Lastly, the unsung heroes: adhesives, seals, and lubricants. From epoxy resins that bond components to specialized lubricants that reduce friction, these materials ensure everything functions smoothly in the vacuum of space. Every spacecraft is a marvel of engineering, a symphony of materials and thoughtful design. From the rockets that launch them to the interplanetary probes they become, each piece plays a vital role in pushing the boundaries of our cosmic exploration. But how do we get from blueprints to the final product? It all starts with meticulous planning and design. Engineers test models in wind tunnels and simulate space conditions to ensure every component can withstand the rigors of space travel. Propulsion systems are another critical aspect. Rocket engines must be powerful, yet efficient to propel spacecraft beyond Earth's atmosphere. Fuel systems, often using cryogenic fuels, are designed to store and deliver the necessary energy for these powerful engines. Navigation systems, including gyroscopes and star trackers, guide the spacecraft on its journey through the cosmos. Communication systems ensure that we stay in touch with our space explorers, using deep space network antennas to send and receive data. And when it's time to return, landing systems, including parachutes and retro rockets, bring our spacecraft safely back to Earth. Maintenance in space is also crucial. Astronauts must be able to repair and maintain their spacecraft to ensure long-term missions are successful. As we look to the future, new concepts and technologies will continue to evolve, pushing the boundaries of what's possible in space exploration. International collaboration is key, with space agencies around the world working together to achieve common goals. From historic missions to future endeavors, each step we take brings us closer to understanding the vast universe we inhabit. So, the next time you see a rocket launch, remember the incredible journey that each spacecraft undertakes, from design to deployment. It's a testament to human ingenuity and our unending quest to explore the final frontier. And who knows, maybe one day, you'll be part of this cosmic adventure, contributing to the next great leap in space exploration. Until then, keep looking up, keep dreaming, and keep exploring the wonders of the universe. The cosmos awaits, and the journey has only just begun.